In this video, I want to talk about the chi-square tests that we perform with two-way tables. And I'll give an example of each kind and show you what I mean by two-way tables. But there are two types of tests that we run for categorical data that's presented in a two-way table. Two types of chi-square tests. And it really has to do with how our data was gathered. So if the data was gathered from two independent random samples, so two different populations, to see if the two groups are the same or different, this is a chi-square test for homogeneity. And our null for this is that the distributions from the populations are the same, and our alternative would be that the distribution from the populations are not the same or are different. And again, we'll see an example of this in a moment. But again, this should be really looking to see, did I take it from two or more? I should say two or more. Then the other type is if the data was gathered from a single sample, but we collected two pieces of information from each individual. So this is one sample, but each person provided two answers. You know, they maybe answered, what age are you and how are you going to vote in the upcoming election or something like that. So again, this takes some careful reading of the problem. And this is what's called the chi-square test for independence. And the null is that the basically response kind of variable is independent of the explanatory variable. And the alternative is that it is not. Now, I'm going to run these tests in a different video because the actual running of the test is very, very similar. Really, what it comes down to is deciding which one you're going to use based on the kind of sampling technique that was done, and then getting the correct null and alternative. And then after that, the test proceeds through the same way with the same types of conditions, running it the same way on your calculator. The statistic would be calculated the same way. The p-value is interpreted the same way. Of course, because your null and alternative are different, your ultimate conclusion will be different. You know, you'll, instead of, if you rejected, you'd say, okay, I have evidence that the populations aren't the same, or, oh, I have evidence that the response variable isn't independent of the explanatory. Your final conclusion will be different because your null and alternative work. But the kind of in-between parts, the running the test, is the same. And let's look at an example. Random samples were taken in 2019 and 2023 asking working adults how they commuted to work. The results are in the table below. If we're interested to see if there's been a shift in the way people commute to work, what would be the appropriate tests to run? First thing, because I said I would talk about a two-way table, this is what I meant by a two-way table. You can see that we've got four different choices for commuting, and we've collected from 2 years. So we have got two categories for years, four categories for the way people commute. This is a two-way. We've split it twice, two separate categories, or two separate categorizations. So this is different than the goodness of fit test, which would have basically taken one sample and compared that to some expected from earlier. Now we're actually comparing these to each other. And that's the important thing. We took two different samples, right? One in 2019, one in 2023. So there are two separate independent samples taken. This is the chi-square test for homogeneity. Okay? And on an AP exam, important to say that. Don't just write chi-square test, because we have three kinds. We've got the goodness of fit, we've got the test for homogeneity, and we've got the test for independence. Now, our null, let's put this together now with some context, is the null would be there's no difference in the distribution of commuting methods between the 2 years. And again, just based on our sample. The alternative would be there is a difference in the distribution of commuting methods. You could word this in other ways for sure. But those are essentially what we're doing. We're trying to see if there is a difference in those 2 years. Now, again, another video I have after this will actually run the test. I just wanted to be able to tell the difference. So let's look at another example. A random sample of working adults was taken that collected information about the level of education and work location for each person. The data is shown below. So again, a two-way table here. We have three categorizations of education. We have three categorizations of kind of their work site. Okay, if we're interested in if there's a relationship between the level of education and the work location of the individual, what would be the appropriate test to run? Important thing here is we took one random sample that collected two pieces of information. Essentially, we asked each person, what was your level of education and where are you working? So this is the chi-square test for independence because one random sample. The null would be the work site. I'm going to use this. I think that would be more correct. Is independent of education level. And the alternative is that work site is not independent of education level. And I will have a video that goes through the actual running of these tests. But again, I just wanted to make sure that we could tell the difference and that we could get the null and alternative. The major difference between the two is at the very beginning, did we take two independent samples or did we take one sample and basically categorize each person two ways? The tough thing about this test is that the data is always presented to you in tables that look exactly the same. So you've got to be very careful. You got to almost go back and just reread how did we gather our information. And then make sure your null and alternatives are set up correctly. For homogeneity, remember we're trying to say there is no difference. The null is there is no difference in the distributions. The alternative would be there is. So for example, in this question, if I had said I took three random samples of people with no high school diploma, and college diploma and asked them, well, then it would be homogeneity. And my null would be there's no difference in the distribution of where people work based on their education level. And my alternative would be that there is. So these tests can kind of run together, and that's why it's so careful to read. If this video helped you, please like and subscribe for more math help.